Hello and good morning. Well, we're clocking in at noon, but I hope you had a wonderful morning listening to the amazing sessions we had lined up for GitHub Satellite India. Thanks for tuning into this session. My name is Shruti Chaturvedi, and I am a backend engineer building scalable solutions at Connexa.AI. Imagine a world where teams would not have to spend months trying to recreate experiments their colleagues did. And the good news is, in this session, we'll take a sneak peek right into that world. We'll be looking at GitHub as an amazing tool to build, test, deploy, monitor, and version ML models and assets to allow faster and iterative development. So it's pretty amazing, and let's get started. So MLOps is essentially an engineering approach to accelerate the adoption of machine learning into your business solutions. And when we are looking at continuous X's in MLOps, there are quite a few. So continuously training your models to achieve better performance and higher accuracy over time. So whether that's through retuning your hyperparameters or changing the base algorithms itself, all of that counts as continuous training. Continuously delivering your updated models to the end users, because that's a crucial step. We then have continuous integration, which is an important concept in DevOps and MLOps alike, which means you're continuously integrating your local changes across to production code, which then gets continuously delivered to the end users. And continuous monitoring to make sure that your data, assets, and pipelines work the way you want. So by using GitHub at the center of MLOps enables building ML models, versioning data and assets, tracking and testing ML experiments, and deploying machine learning solutions super easy. So these are some of the tools and services we will be using to build a binary classification pipeline. So we are using something called a DVC, or a data version control, which is a open source tool available for free to use. And it sits right on top of Git, and we'll be using it to build and version our pipeline. And we'll use GitHub to orchestrate the pipeline and also to enable us to share those versioned assets between different team members. All right, so let's move into the coding now. We will be building a binary classification pipeline, as I said earlier, and we are using a cancer survival data set. All of the code is being hosted by GitHub, and DVC will very beautifully push all of the data pointers onto GitHub on all of the tracked assets as well. Also, we'll be looking at some super cool automation tool called GitHub Workflows to do a lot of the heavy lifting for us and also solve the problem of comparing performance between different models. With that, let's head over to GitHub. And we will begin by cloning this GitHub repository onto our local system. So this is going to act as our source of truth. And whatever is into the master branch right now is what is onto production. So whatever is here is being supplied to my consumers. And my job as a data scientist who is joining this team is going to be taking this accuracy and making it more accurate. Right. And like, it seems pretty feasible. So let's see if we are capable of doing that. Let's switch over and see what do we have. So here we have 3 different scripts, and we'll begin by looking at getData.py. So this is where we are getting our data from and storing it in our local system as Haberman.csv. So let's switch and see how our data looks like. All right, so we have 3 different independent variables and 1 dependent variables. And this is what we are trying to predict, whether a person survived after cancer treatment or not. So all of these are numerical. This is the age of a person, the year in which the operation was conducted. So 1964 here. And the 3rd column is an indication of how spread out the cancer was. And again, 1 means that a person survived and 2 means that it did not. Let's switch back over to VS Code and look into our process data script. So this is where we are taking that dependent variable values of 1 and 2 and encoding that into a more standard format by using a label encoder and transforming it into a 0 and a 1 and storing that into our local system as Haberman process.csv. After that's done, we're going to move into training script. And this is where we are loading our Haberman process.csv, transforming that into a data frame. And then we're running a normalizer just to ensure that all of our the independent variables are normalized across their values. So what's into production right now and what my users are receiving is a simple logistic regression model, right? Like makes sense why the accuracy wasn't so great. And we are pulling in parameters from params.yaml file. So that's a pretty interesting file. Make note of that. We'll be looking at that in a second. We also have a bunch of metrics. We have accuracy, specificity, and sensitivity. And what we are doing with those metrics is dumping them into a metrics.json file. And what this is going to do in the future is help the code reviewers and the mergers to look at metrics.json at a master branch and metrics.json at a different branch, which we are working on, and be able to tell if this is something that they want to merge based on the accuracy and all the metrics. A little bit of continuous delivery aspect here. We are using a GitHub workflow, the super interesting tool that I talked about. We'll be looking at how we have configured that. So as soon as a model is pushed onto master, so as soon as maybe we have a pull request into master, we are going to put the final model into the inference service. So what I'm using is AWS, but it can really be anything. Switch over to params.yaml, and this is where we have defined all of our hyperparameters. We just have two, but you can define however many you like. And this is where my training data script, or this script right here, is calling my parameters from. So I'll only have to tune them and change them here rather than switching back and forth between train data and different scripts. Now, how I want to design my pipeline is for all of these steps to run sequentially, getting the data, processing the data, training the data. And also I want a way so that as soon as my parameters change, the training script should run again and produce a new model. So how we have configured that is through DVC pipeline, and this is the pipeline config file, so dvc.yaml. So we have 3 different stages, and all of them are going to run sequentially. And DVC is tracking each of these stages, and it's going to track the outputs and the dependencies of each of these stages together. So as soon as a person runs their pipeline using DVC repro, what DVC is going to do is look into its local cache folder, which we do not have right now since we have not run the pipeline. And it's going to see if a particular script has changed or if a particular data is missing. And DVC is only going to run that stage. So consider that you're gone on a vacation for 2 months, and then you return back and params.yaml has changed significantly. So you pull all of your code from GitHub, and all you'll have to do is run DVC repro, and it's going to see what has changed, going to run the train data script, going to produce the final model and put that in your local system to ensure that you have the exact same experiment and model that your colleagues do. Let's just take a look at what do we have? Okay, not the command I wanted to run, but never mind. We are going to try again. Okay, let's clear this out, run DVC status just to see where we are in this whole process. Okay, so none of these files are in my cache. So when I run DVC repro, DVC is going to run all of these stages, pull in a new cache folder over here in the DVC folder, and as it goes through the stages, it's going to put the outputs in the cache. So as it's going through different stage, it's going to get the output and put that into cache. Let's see if that happens and if we are lucky enough to see that. Okay, well, it seems that we are kind of lucky. Okay, it seems to be working. And as soon as this is completed, what happens is if I was to turn over to my git ignore, so GitHub is not tracking all of these data files. Instead, what we are pushing onto GitHub is actually pointers to where my data is stored. And that's honestly such a smart way because you have pointers to each of the versions of the assets that you're producing. So now what I want to do is check out a new branch and let's see, let's switch over to train data. Where is it? Okay. And what we want to do is use a multinomial naive Bayes model. Since our job is to make this whole system more accurate, let's try out. Okay, perfect. Let's try a multinomial naive Bayes. And here is our classifier. So I'm just going to change it to using multinomial and B, and we're going to comment this line out. So now what I want to do is run DVC repro again. So the training data is the only script that has changed. It's going to reproduce a new model and will put that into my cache. And I am going to track that particular new model with GitHub. So as soon as that's done, let's take a shot of where we at, or just to make sure that everything remains intact and doesn't break. All right, so let's push this onto Origin. And as we push it onto GitHub, we'll see such a cool thing that's gonna trigger there. So should we switch over to GitHub and see what's going on? All right, head over to the Actions tab. Let's see. Awesome. So something just got queued and it seems to be running a workflow, right? It's like a whole bunch of steps which are running. So where did we configure it and how is this running? All super good questions which we are going to answer. So let's look at the GitHub/workflows and workflow.yaml file. Okay. So a workflow is essentially defining on high level what needs to be done. And what I want is, as soon as I push onto any branch onto GitHub, I want to run this particular script. I want to run this job called run pipeline, which is going to run on an Ubuntu latest machine. And in Ubuntu, all of this machine is actually configured with this container, which has pip install, dvc, etc. And all of this is running on GitHub provision machines called GitHub runners. And GitHub runner is going to be configured with something called, so we are running these as steps. And when we have these steps, we're using something called an action. And that's like a predefined sort of term or predefined task that we want to do. So here, what we want to do is check out action/checkout. We want to check out all of our code onto that GitHub runner. So that GitHub runner will be able to look at my code and then do whatever it wants to do. So it has these secrets on GitHub token, which is getting it access to read and writing from my repository, which we'll look at where the secrets are stored. So as soon as it has all the code onto the runner, we are going to install the requirements. We're going to reproduce the entire same pipeline that we did on our local system by using DVC repro. We are going to fetch how the tree is looking like on GitHub. And then there are two things that we're doing, which are super cool, is we're looking at the metrics.json and params.yaml at the master branch. And then we're looking at metrics.json and params.yaml at different branch and comparing them. And then we're sending that as a comment to that particular commit. And what that's going to do is, again, help the code reviewer see and understand if this is something they want to push into production. So this action still seems to be running. Meanwhile, let's switch back and check out. Oh, wait, did it? Okay, we will come back to that in a bit. Let's also check out another branch and let's try LDA here. So what I'm going to do is let's have a discriminant analysis, right? I'm just going to try out all of my luck and see which model works best and take credit for all of that work. So let's also comment this line out. So again, we are going to do the exact same step. We are going to run DVC repro to ensure that our new model is on us and it's also with our teammates. Like working with a team is really important to ensure that everything runs smoothly. Okay. So once that's done, let's add our files and make a git commit. Let's say LDA, not a super descriptive comment, but that works. Git push origin, and let's push it to LDA. So from previous experience, we know what an action should have been triggered, right? Okay, well, not yet. So it just got pushed and it's running. So let it run. We can look to our push that we made onto the multinomial naive-based model and see what do we have on there. We know that we were looking for a comment, right? And let's see what this comment is going to look like. Okay, so it seems that we kind of did worse by using a multinomial naive-based model. And right now, I'm a code reviewer, right? I don't want to push this into master because the sensitivity, the accuracy, really not what I like. So I'm just going to do nothing with it, and I'm going to wait on LDA, which my team member has pushed. Okay, so switching back, let's look over to the other deployment file that we have, which is called deploy to AWS. And this is another GitHub workflow. What I want to do here is directly deploy to AWS. So as soon as I push onto master, or the code reviewers push onto master, what this is going to do is take all of the code, package into a zip folder, and then put it directly into AWS. I will not have to do anything, will not have to switch over to AWS, will not have to configure steps over there. Very simple, very nice. So here are certain environment variables which we're using in this workflow. So again, like last time, we were checking out this repository onto the GitHub runner. Then we are creating a deployment package using like a standard command line tool. And then we are configuring AWS using something called AWS Actions. And these are actions made available by AWS themselves. So these are open source, you can check them out. And what this particular action is going to do is check out, or it's going to configure the AWS CLI onto the GitHub runner with secrets and access key ID, just to ensure that that GitHub runner has access to all of my resources. So it's able to pull or push or read and write onto different resources. Here it's just S3. And where these secrets are stored is back here onto settings. Switching over to secrets, this is where we have secrets defined, and you can create a new repository secret, and that's how your workflow.yaml file is using these secrets from. So that is for the second script. Let's see what happened with our actions. Okay, so that's good that it got completed. And okay, so this was an LDA branch. Let's see what's going on with this branch. We are hoping to see something better, like something positive at least. So, okay, that's a good sign. We have a quite significant change in accuracy and sensitivity. So I don't really care about maybe specificity here. So what I'm going to do is I'm just going to create a pull request onto master. And we know that as I compare a pull request with master, our second workflow, the YAML file, which was to deploy to AWS, is going to get triggered. So switching back here, let's refresh this. Okay, not yet. Okay, let's see if we actually merged changes. Okay, it's still. Okay, never mind, we never merged it. Let's confirm the merge. So now we should go back to actions and see something. So that's good. So we have two of our workflows running. We have a deploy to AWS workflow, and we have the one that we were using previously to compare metrics. So as soon as these get completed, we can switch over to AWS and see what's going to happen, right? Let's see. So this is, okay, this got completed, so that's good. Also, one thing that I wanted to show is what would happen if there was an error in your script, right? So if I made an intentional error earlier just for demonstration, and I wanted to show as there is an error, you can go and check into your logs where exactly is that error, and you'll be able to resolve it and run it again. So I absolutely love that continuous testing and monitoring part just to make sure that everything works. So switch over to S3. And let's refresh this. And we should have a new zip deployment file if everything works, including my internet. Okay. Ooh, awesome. I'm so glad. So this is our zip deployment file, and this contains all the updated code. So anyone, I can, if I have some different setup, which is using deployment from here, we can switch back and use that. So that was for me using a very, a big way and a very sort of complete way of doing an end-to-end machine learning pipeline. You're versioning the system, you're testing it, you're configuring it, you're trying and making sure that different algorithms are getting configured and your branch managers are able to see and sort of tell if this is something that they want to go into production. And I really do think that with AWS and with GitHub Actions and workflows, every development of any sort is really sky is the limit, essentially. So that's a wrap for this session, and it's time for Q&A. You can also head over to githubsatellite.com/discussions. We're going to be there and answering all your questions about GitHub workflows and actions and how we are using it and how you can use it. All right, so thank you so much. Let's head back.
Thank you, Shruti. That was an awesome session, and love the demo gods as well as internet gods, like everybody played along. The first question that I have for you is, how has data version controls like DVC's functionality been amplified by GitHub?
Yeah, so I really like this question, because imagine if you have like a team of people you're working with, right? And like you have data coming in every day, and like you're trying to build, you're trying to version, and it gets so complicated that there's no way for you, you're versioning it, but there's no way for you to share those versions between your teams. So maybe you're emailing one person, maybe you're WhatsApping your code and your data to the other person. And like, just imagine that one person gets one data, the other person gets the other data, which is not going to work for your team. So GitHub, a very central role that it's playing is making sure that every team member can switch between different versions, and it acts as a source of truth, and everything works for the entire team rather than just the person who is working on that particular assets and those questions.
Great. Thanks for that insight. We also learned in your introduction about you being at Connexa.AI, which is an all-women-led startup. Would love to hear more about how's it working like at that place and what is the story behind it. So tell us more about Connexa.AI.
Yeah, absolutely. I absolutely love working there. It's all women. It's all women of color who are running the team, all super powerful. And how it was actually started during these COVID months and during the lockdown, where the CEO thought that there's not a lot of women who are leading in the space of AI and leading in the space of startups. So Maria Punawala, that's the person who's leading it, she thought, let's get together a team of amazing women developers who are really excited about getting into this space and like building software. And within like 2 months, there was so much positive comments and like positive feedback we were receiving from people. And we are just going to launch our new MVP product. And it's so fun working with dynamic women from, even different countries. We have people from Portugal, from Brazil, from Canada, all amazing. And over there as well, I'm always sort of pushing for using GitHub Actions. I'm like, let's go. This is such a great system, because I am managing like serverless infrastructure deployments there. And I'm always like, you know what? Let's use GitHub Actions. It's so cool. Absolutely love it.
Thank you. And a big shout out to all your leaders there for thinking about it and starting something which like all of you feel so passionate about. Yes, big shout out to all of them there. The question I have for you is, in the roadmap for actions, like what are the big pieces you're looking forward to?
Yeah. Well, whenever I'm thinking of actions or like GitHub Actions, there's such a great space and like, first of all, an amazing developer community who is like building the actions to make sure that all of the platforms and the systems, you have AWS, you have Azure, and GCP, which was the session we had earlier, which was using actions in GCP. It's such a wholesome environment of building and making sure that all of the developer community, whether they're building with Python or they're building with Java, JavaScript, they all feel comfortable, and that's such a big thing. And especially how it gets configured and built together with the GitHub workflow. Also the openness that you have, you can like choose between different options, and just the docs themselves, they're so cool. Absolutely. I'm always looking at the marketplace and I always get so excited. I'm like, whoa, a new action in the marketplace. That's so cool. So yeah, I would always support and push for GitHub Actions as much as I can.
Wow, that was music to my ears. And you talk about a lot of GitHub features and capabilities here. We got this interesting question to almost every speaker, and here it is for you as well. If you got to pick one feature which is your favorite in GitHub, what would that be?
And now this time you can't say
I
actions.
would say it's probably discussions. That's what I'm gonna say. Because it's bringing that developer community together, like we are able to talk, we are able to discuss things, and it's always such a good thing to receive feedback, right? And just like talk with the community, and GitHub has such an amazing developer community, and it's always growing. Yes, and that's so cool that this feature was implemented. You can go in, you can talk, you can talk about what you want to build, you can talk about what the problems are. I would always say, discussions. All actions would come second.
Wow. I love talking to you. You're like a super fan of GitHub. So I thank you so much there. Another one that I see coming up is how, especially again, coming to ML Ops, bringing data scientists and engineers together. Like what's one thing you would want to share of how can they start collaborating much more better?
Yeah, no, that's a really wonderful question. And I would say that, it's such a broad infrastructure, like ML and ML Ops is such a broad infrastructure. And with their different aspects, you have the ETL with data, then you have like the training of it, then you have the deploying of it. But it's such a central system, especially with like tools and services like GitHub. It's like such a central system that whatever everyone is working on, they can collaborate very easily. And also they can sort of see the team movement as they move through different processes. So the whole ecosystem of developer engineers and ML ops, I think it's a great infrastructure for, especially for me. I love being in this infrastructure, and I love being able to contribute to not just the ML part of deploying things, or not just the ML part of training the data itself, but also the whole infrastructure of how or where the data is coming in from, and how we can design it, and how we can make it more suitable to the users. That continuous feedback from the team and users, super essential.
Wow. You packed a lot of goodness in this talk, and we're going to tell our viewers that you are not leaving them for another 30 minutes, and you will be with them at GitHub discussions. So we'll take your leave, and bye-bye, Shruti. But viewers, do throw all your queries, all your questions to her at GitHub discussions.